Welcome, y'all. This will be our last section for this. There is one more section. It's about perpendicular in the distance, but we talked about the distance one already, and we did talk about perpendicular lines. And I'm not going to test necessarily on finding the distance between perpendicular lines because it's not one of those very heavily important things, and it's a lot. I want to focus on the things that matter the most instead of just all these other things that fill it. And we're going to go over perpendicular lines and distance in a later chapters. So we're going to focus on this right here being our last one. So parallel lines have so much in common, but they never meet. So as we talked before, we talked about, I think in 3.2, all these theorems and postulates that are true about angles of parallel lines. Well, we're going to then flip it. This whole section right here, 3.5, is kind of like a converse to 3.2. They always said, if your lines are parallel, then this is true. If your lines are parallel, then this is true. So before you were saying, so ignoring this for a second, they would say, if your lines are parallel, then corresponding angles are congruent. So we're doing the opposite. We're going to prove that if we can prove that two lines cut by transversal, and if I can prove that these two angles, the corresponding angles, are congruent, then that proves the lines are parallel. So we're trying to prove lines are parallel, and that's how you do it, just by doing the math of it. So as we remember, corresponding angles are two angles in the relatively the same spot, just on different lines. So both of these right here, 2 and 6, are top right angles, so they're corresponding to each other in this group. This group top right, and this group top right. So from what we remember last time, they should be congruent. So to prove that, we're going to make it, we got to figure out what x has to be to where they give us the same answer. So if two angles are congruent, so if angle 2 is congruent to angle 6, their equations then are equal to each other. Well, that's how we'll set it up. We'll say 11x minus 25 equals 7x plus 35. And then from there, it's just good old math. So let's get our x's on the same side. So we're going to subtract by 7x. You get 4x minus 25 equals 35. And then from there, we're going to go ahead and get the number both. So add 25 to both sides. We're going to be getting 4x equals 50, 60. Right there. And then the rest is just division. Divide by 4, divide by 4. X equals 15. Well, let's double check that then. Let's plug that in here. Let's see if we get the exact same answer. So I'm going to bring up my calculator. You can't see it from your end, but I can see it from my end. So we're going to do 11 times 15. So 11 times 15 is 55. Not 15. 11 times 50. I put 50. I put 5. 11 times 15. There we go. 165. Sorry, 165 minus 25 gives me 140. Minus 25 equals 140. All right, let's do it down here. 7 times 15 is 105 plus the 35 is 140. Look at that. They're the exact same. So we did good. Good job, y'all. All right, next one here. So it's called a parallel postulate. Now, this is important because sometimes you got to make up your own line. So it's just saying that there's some outside line out here, through a point outside this one line, so this is the point we're talking about right here, there can only exist one parallel line. I can draw an infinite number of lines over that one point right here, but there will only be one that is parallel to it. That'll be in the same manner. Let's see. Let's take that. Let's take this and move it. Oh, look at that. It goes right over it perfectly. There can only be one set of parallel. Now, like I said, you can draw thousands and thousands of lines, but there's only one that be parallel for sure. But back to some more things. So alternate exterior angles. If you remember, alternate exterior angles are the two angles that are on the outside of each other. Alternate. Okay, they're opposite sides of the parallel lines, opposite sides of the transversal, and they're on the outside of the parallel lines. So if we can prove that 4 is congruent to 2 and that 1's congruent to 3, and then we did that. So I got a little problem right here. Let's try that out. So If we're saying these are congruent, then we're saying these equations are equal. So go ahead and pause the video and then do the math behind that. Hopefully you paused. You can figure it out and find what x is. Let's see what it is. So you'll set it up as 4x minus 23 equals 2x plus 17 right there. So just like before, get our x's on the same side. You're getting 2x minus 23 equals 17. So then I'm going to add 23 both sides, plus 23. I get 2x equals 30, 40. 40 divided by 2, x equals 20. So if I plug this in right here, 4 times 20 is 80, minus 23, 57. Here, 2 times 20 is 40, plus 17 is 57. Yeah, we get the same answer. Good. Next one right here, alternate interior. Remember, these are the two angles opposite side of the transversal, but both in between the two parallel lines. So 1 and 4, 3 and 2. If we can prove that these two equal each other and these two equal each other, that proves that the lines are parallel. That's what we're trying to do. So right here, we're going to use 2 and 3. We're going to say 2 is 2x minus 21, and 3 is 5x plus 7. If the angles are congruent, then the equations themselves are equal. So pause it and solve for x. All right. So you set it up like this. Same concept here. You get the x on the same side. Minus 5x, plus 21, plus 21. That goes away. That goes away. We get 2x equals 28 here. Divided by 2. X equals 14. All right. Let's plug those in just to double check. So we get 7 times 14 equals 98 minus 21. Let's get 77 on this side. 5 times 14, you get 70 plus 7. Ooh, you get 77 on both sides. Look at that. All right. Hopefully I'm not talking too fast. I had some really good coffee this morning. Now the perpendicular transverse converse theorem, that's a transversal converse theorem. It's a long thing, but it's just saying, if you know for sure two lines are perpendicular to the exact one line, then those lines have to be parallel. Previous to this, back in 3.2, we talked about how if one line is perpendicular to the other one, and these two lines are parallel, then that says that these two angles are perpendicular. They're both perpendicular. Here we're saying it backwards. We know these are perpendicular, but because they're both perpendicular to the same one line, these have to be parallel. So we're proving parallelness here. So this proves parallelness. Consecutive interior angles. Now, if we remember, consecutive interior angles are just that. Consecutive meaning right next to each other on the same side of the transversal. So 1 and 3 are consecutive interior angles, and 2 and 4 are consecutive interior angles. The great thing about consecutive interior angles is they're supplementary. They have to equal 180 together. Okay, so that's what I prove. If I can just add, if angle 1 and angle 3 add up to be 180, then they're parallel. These lines are parallel right here. So we're gonna write a little theorem about that, or we're gonna write a two-column proof. So we're gonna say 1 and 2 are supplementary. 1 and 2 are supplementary. We're gonna prove the lines are parallel without any actual numbers. Now you're gonna have to do this. I'm telling you right now, there'll be a problem just like this on your test. So if you have a hard time understanding this, let me know and we can kind of walk through this. I will be putting on later next week. There will be just one video going just over 3 different examples of these kind of problems. And of course, you'll have your review for the test. All right. So we start with our given information. Angle 1 and angle 2 are supplementary. That's given. So I can also say, hey, by just definition, I can say angle 2 and angle 3 are supplementary. Why do I know they're supplementary? Well, because what is angle 2 and angle 3? they're a linear pair. So by definition of linear pair, I can say they're supplementary, 2 and 3. Well, if 1 and 2 are supplementary, and 2 and 3 are supplementary, then 1, angle 1, and angle 3 are congruent. If these two equal 180 and these two equal 180, these two have to be the same. That's the definition of supplementary angles. Now, congruent, sorry. Supplementary definition of congruent supplementary angles. Of congruent supplementary angles. Now, if we don't remember that right there, I mean, this is the here thing. You will be using this on the test. I'm telling you right now, this will be one of the answers on the test for the reason. Because 1 and 3 are because 1 and 2 make 180, and 1 and 3 make 180, then they are congruent. These two have to be congruent. Because if two different angles make 180 with the exact same one angle, in that case 2 being the angle, these two have to be congruent. So angle line A is parallel to line B because we just proved that 1 and 3 are congruent to each other. And if they're congruent, what kind of angles are these, 1 and 3? They are corresponding angles. So line A is parallel to line B because corresponding angles are congruent. So I'm going to make a little thing. So what proves lines parallel? What proves lines parallel? If we can show one thing, we can show corresponding angles. Corresponding angles are congruent. So we can prove that's congruent to that, or any version of that. If we can prove alternate interior angles are congruent. If we can prove alternate exterior angles are congruent, or I can show consecutive interior angles are supplementary. If I can prove one of those 4 things, that proves that those lines are parallel. Okay? Hopefully that kind of helps. So our goal is always to get to some version of this, to show these are corresponding, to show the angles are alternate interior, to show angles alternate exterior. If I can show those, then I am solid. Y'all have a great day.